Welcome back, everybody. This is going to be our part two of homework number 35, lesson 35, the volume of prisms and cylinders. Here we're going to continue with kind of, trying to find a volume within a volume, sort of the idea of like we take a volume and subtract a volume from here, almost a shaded region situation. The piece of hardware constructed by drilling a cylindrical hole through a right prism with a square base that measures 20 millimeters on each side. The hole is 35 millimeters long, as shown in the diagram. Determine the volume of the remaining material once the hole has been drilled, and round your answer to the nearest cubic millimeter. So we have two volumes. Our volume of the box, and with a square base, it's going to be 20 millimeters by 20 millimeters, and the height will be 35. So we're going to do 20 times 20 times 35. Then we're going to find the volume of the cylinder. And that's going to be, in this case, pi. Now, if the diameter of the circle is same as the measure of the edge of the box, in this case, this spot, the base, is 20, our radius has to be 10 millimeters. So we're going to take pi, multiply that by 10 squared times 35. And then we're looking for our volume, in this case, would be the volume of the box minus the volume of the cylinder. So let's find each, all right? Well, 20 times 35, that's going to be 700. And then 700 times another 20, well, that's going to be, I believe, 14,000. Okay? That was okay, no problem. So that's 14,000 millimeters squared. Cubed, actually, cubed for volumes, cubic millimeter. Now, for the cylinder, we're going to get some decimals, so we need to break out a calculator. So we're going to take pi and multiply by 10 squared, and then multiply that by 35. And we're going to get 10,995.57. So we'll break it down with 10,995.57. 10,995.57 ... and that's millimeters cubed as well. Now we're trying to figure out the remaining material, so we're going to take those two values and subtract. All right, so we, just to make sure, because like, well, how you know you got the right Mr. Gong before? Okay, so let's do, in this case, 20 squared. That's 20 times 20 times 35. Just in case, just in case I got that wrong, which I don't think so, but that's okay. I don't mind double checking my work. 14,000. There you go. Now, so minus, and then what we can do is bring the cursor up to this spot here. And let's highlight it, hit enter, and now that's transposed. And hit enter again, and now we get 3,004.42571. So that's the number of cubic millimeters we're going to have. And rounding up to the nearest, I believe it said nearest whole cubic millimeter, so it'll be 3,004 cubic millimeters. And this will be the answer we have for question number 5. So it's just very similar to shaded region problems, except you find the volume of the large volume, minus the volume of the small piece, which is the cylinder being taken out. Okay, so that's question number 5, all right? And now question number 6. A prism has bases that are equilateral triangles with sides lengths of 10 inches and a length of 30 inches, so depth 50 in this case. Find the volume of the prism to the nearest cubic inch. And of course, show your work. So I want to find our base area. So the base area is 1/2 base times height for the triangle, but our equilateral triangle in this case, let's see if I can get an equilateral triangle here. Here we go. And so here's our equilateral triangle. What is going on? Here we go. All right, that's okay. Totally good. If we can make this a little bigger. Yeah, maybe a little bigger. There you go. There you go. All right, so we know that this base here is going to be 10. and equilateral, this size here 10. So we want to find out the height. And so this height here is going to be, if it's an equilateral triangle, is height here is also going to be the angle bisector and of course also the median. Therefore, we find out that for this triangle, this is going to be 5. So if we use Pythagorean theorem, we could find out the height here. But we've already encountered this with our special right triangles. So what do you mean? This is really going to be a 30, 69 triangle. That's 90, here's 60, and here is 30. We know the side opposite, the side opposite of the 30 degrees is 5. The side opposite the 90 degrees is twice that, or 10. And then the side opposite the 60 degrees is going to be 5 square root of 3. But just in case you're not sure, you say, oh, can you prove it to me? Sure. 5 squared plus b squared is equal to 10 squared. So we have 25 plus b squared is equal to 100. B squared equals 75. So b is equal to the square root of 75, or in this case, 5 square root of 3. And so now our height is 5 square root of 3. Okay, so the base area, going back to the base area here, is equal to 1/2 times 10 times 5 square root of 3. Or in this case, our base area is going to be 25 square root of 3. Okay? But our volume, if we remember, is going to be the base area times the height. So that will be 25 square root of 3 times 30. And so, well, 30 times 25, it's like saying how much would you have? You have 30 quarters, right? Well, that would be, well, 3 times 25 is 75, times 10 is 750. So we'll have, in this case, 750 square root of 3. But they want us to find, remember, to nearest cubic inch. So we're going to have to set this up on our calculator, all right? So we're going to take 750 cubic times square root of 3. All right. So 750 square root of 3. And now we're going to find our answer to be 1,299.038, or in so approximately 1,299. Just double check, make sure that down correctly. Yes. Okay. And that'll be inches cubed. Now, this is the last question we'll cover in part 2, but now I want to go over this again with another formula that you might not be familiar with. And you're saying, well, what do you mean, Mr. Gong? Okay, now for equilateral triangles, let me first show you the full page. Take a look at this. Okay, if you want to take a look at this out. Now, if you want to pause, copy this all down, that's totally good. Because now I'm going to give you a different formula for area of an equilateral triangle. All right, so I'm going to erase all this stuff here. Use the big eraser. There should be a big eraser here, right? Okay. So now, the formula that makes things easier, because we'll call this side and this side and this side. So the area of an equilateral triangle is really going to be the side squared times the square root of 3 over 4. Saying, well, how does that work out? Well, consider in this case that your base, the base is equal to s, and the height is going to be equal to this 1/2 of the side times square root of 3. All right. Remember, this part here is the side over 2, s over 2. And therefore, we'll take this measurement and multiply by square root of 3, s over 2 square root of 3. So if you multiply, so in this case, the height is s over 2 square root of 3. So the area is equal to 1/2 times the side over 2 times square root of 3. Well, you're just going to get side squared times the square root of 3, and the denominator is multiplied by 4. And so we take this and then take this, we're gonna get 10 squared times square root of 3 over 4. That's the same as 100 over 4 square root of 3, or 25 square root of 3. And that's it though. So from here we're going to multiply. Our volume is going to be 25 square root of 3 times 30, which is the same thing as 750 square root of 3, approximating to 1,299 inches cubed. Now I want to show it to you because I like showing alternative formulas for certain areas, because sometimes what you can do is use the altitude and find the height from there using Pythagorean theorem. That's totally good, but it's also useful to be able to know different formulas for certain figures, especially equilateral triangles. Just knowing if I know the side, I can just square it and multiply the square root of 3 over 4 to find the area. Okay, this will be the end of part 2. And part 3, which is focusing on particular theoretical problem, Cavalieri's principle. I want to spend just time for part 3 only on that question. I hope this video was helpful. I hope that you've been enjoying watching these things. I know we're stuck at home and have to do all this not in the classroom, but I appreciate your willingness to do the work. I appreciate your learning, because the learning is the most important part, ladies and gentlemen. I want to be prepared, because grades mean nothing. It's really the knowledge that you have that means the most important thing. Thanks so much for watching. Please leave any comments or questions in the comment section below. Give this video a like if you really found it helpful, and watch out for part 3. Okay, watch out for part 3, and look forward to seeing you then. Take care and be safe. Be safe.